Can you guys hear me? Cool. So my name is Steven Siciliano. I'll be talking about logic apps today. It looks like there's lots of room, so maybe people were really tired from partying last night, but hopefully those of you that decide to come out will be rewarded graciously. So what I'm going to be doing today is I'm going to be talking about integration in Azure. So I'll start with a little background of how we got to where we are today. I'll give some information on App Service as a platform. Hopefully some of you have heard of App Service before and seen either the announcement or previous talks on App Service. Could I get a show of hands? People have heard of App Service? Awesome. At least over half. So that's a good sign. Then I'll jump into a couple demos and also give you some background on the architecture of Logic Apps, kind of what our inspiration for it was and how it got started. So integration in Azure, we have a few different components that have been working together to release integration in Azure. The most important one is just in March, we announced the preview launch of Azure App Service, which contains API apps and Logic Apps, which are two kind of key components that I'll spend most of the talk discussing. But there are other important milestones that we've had recently that I wanted to cover briefly. Back in February, we GA'd API management. And last year, we GA'd the BizTalk Server 2013 R2. One of the key things with what we're working on, Azure App Service and Logic Apps, is we want to get a lot of community engagement. So we've been working very closely with the community. We've been communicating very regularly, doing blog posts. And coming at WPC, we'll also have awards for some of the coolest app partner integrations. So stay tuned for that. So jumping into building applications for Azure, we really see it as there being three key pillars for building an application that makes Azure differentiated from, say, building an application and running it on-premise in your own data center or not using any components from Microsoft. The first is scale. By creating an application on top of Azure, you can elastically grow that application to meet the demand of your customers. And the second is agility. With deployment to the cloud, it's much easier and much faster to rev your code to deliver it in a way that immediately delivers value to your end users. And the third is insights. With insights, you can understand exactly what is happening for your applications and rev your business based on the data that you learn about what's happening. Now, before the app service launched in March, these were the three key services that we had that delivered these capabilities for building applications on top of Azure. Websites, mobile services, and BizTalk services. How many of you have used BizTalk before, either the cloud version or the server product? OK, so a good number as well. So I'm going to spend just a few minutes talking about BizTalk services. And if you're familiar with it, great. If not, maybe I can give a little context just so you can understand. But the reason I bring this up is because BizTalk services, up until the launch of App Service, was our product for integration in Azure. Logic Apps is our product today that I'll spend most of the time talking about. But BizTalk services, it brought in a lot of good value. It validated the key patterns for running integration at cloud scale. And it also demonstrated that hybrid is a key differentiator for Azure. But there were a number of feature and compatibility gaps, which if you've used BizTalk services, you're probably intimately familiar with. I won't go into all of them today, but if you've even heard of BizTalk, there is one key point that I want to hit, and that is the learning curve. So with BizTalk, the learning curve looks a lot like this. It's not really a curve. It's kind of, well, what actually is this wall, right? So it takes days to get started with BizTalk Server, just to install it. And once you install it, you don't even know where to start. It's very difficult to kind of get over that initial hump, that initial wall, and get started with delivering integration solutions. We noticed what was happening is people, instead of trying to work through all of that pain first and then delivering a simple solution, what they would do is they would end up doing a bunch of hacking. So rather than using BizTalk for a simple scenario, they would just hack together a little solution. They would write 20, 200 lines of code. They would use some combination of off-the-box components that didn't really integrate very well together. But to do a simple integration solution, to flow data between their back-end system and their order processing system, or in order to orchestrate across maybe a couple steps when the user submits an order, there would just be a lot of hacking going on. And that's a problem because that's difficult to maintain. It's difficult for you going forward to be able to look at that code and remember what that even did, because it wasn't a particularly notable thing, but it just is there, and it ends up being this key business process that you have inside your business, and everything is built on top of it, and it's just very difficult to go in and change that later. So what we're doing with Logic Apps in the broader app service is trying to make the learning curve look a bit more like this, which is a much more reasonable curve. So it'll start out very easy. You're going to see a couple demos today that in just a few minutes you can get started and understand how to use integration inside of Azure by using Logic Apps. But as time goes on, if you need more advanced capabilities, we also have all of the power that you'd expect to be able to deliver full, powerful solutions as a part of Azure. So this is our goal, is a learning curve that looks a lot like that. Broadening out just a little bit, this is our vision for app service and Logic Apps more specifically. First of all, we want to democratize integration. And what that means is it should be easy for any simple developer, an IT pro, to just get started and use Logic Apps. They don't have to go through arduous days of setup and understanding and learning. The UI should really guide you to just get started in just a few minutes. And hopefully that will dramatically broaden the user base and make people much more willing to use Azure. Second, we see ourselves as being a leader in the iPaaS space. If you're not familiar, iPaaS stands for Integration Platform as a Service. So we're delivering an integration platform as a service so that way you can consume it. And finally, I'll touch on this a bit more later as well, but we see there being a rich ecosystem for Azure here. So for example, there's a variety of connectors that you will be able to contribute to, as well as a series of templates for the Logic Apps themselves. So this is what we had previously, and what we've gone and we've combined it into a single offering called Azure App Service, which is a single integrated offering that brings together all of the best components of our application building capabilities inside of Azure. Specifically, there are four key pillars of app service. The first is web apps, which allow you to build web applications at cloud scale. The second is mobile apps, which build on top of web apps, and they give you, in addition, all of the libraries and capabilities you need to build a mobile application, no matter what the platform. If you're running Windows Phone or iOS or Android, you can take advantage of mobile apps. The third and fourth are Logic Apps and API Apps. So Logic Apps, obviously, that's why you're here today. So I'll go into that in a lot of details. And then API Apps are the RESTful API interfaces for all of the components that you build. You can think of it, the API app represents the contract between your business logic and all of the other components in the system. Before I drill into the specifics of Logic Apps and API Apps, though, I wanted to briefly cover some of the key capabilities that Azure has that are relatively new that you may not know about. All these have come out in the past year, but they're very important for managing a business on top of Azure. The first is there is a full audit log of all the management operations that happen inside of Azure. That means if somebody comes and modifies your application, if somebody deletes a key resource, you can know who it is, so you can go and fire them if you want. You don't have to. Second, there's role-based access control. So what that means is you can grant people specific access to just the components that they need. You don't need to just give everybody keys to the kingdom. You can lock it down so that way a person building just one component of an application can get just the ability to edit that. The third is you can manage the deployment lifecycle with Azure Resource Manager. And what that means is you don't need to go and write a whole bunch of custom scripts, a bunch of custom deployment capabilities in order to deliver an application on top of Azure App Service. You can use built-in capabilities, which I will demo, for example, in Visual Studio, to deploy your application in one single unit. We, of course, have full REST API and PowerShell support. So if you ever want to run anything programmatically, if you think the new portal is not particularly responsive and you want to just drop down into the command line, you can do that as well. And finally, with the release of Azure Stack, you will be able to run everything that you see here today on-premise in your own data center. Hopefully, you've seen some of the demos from earlier in the week with Mark Rusanovich, for example, where he demoed running that same template of deploying, in his example, was VMs, but it applies equally here to Logic Apps, running in the cloud and in an on-premise data center. So, Logic Apps. What are Logic Apps? They give you an easy way, without having to write code, to do integration in the cloud, to automate on top of anything that you would like. We have built-in recipes that you can use, as well as connections to a wide variety of SaaS offerings out there. I'll show you a slide with a whole bunch of names on it. You don't need to read them all, but we're working on making sure that you have connectivity to everything you need. As well, you can build your own custom APIs and integrate them with Logic Apps. So what that means is if you have your own interfaces, if you have your own internal systems that you want to use, you are more than welcome to do that by building API apps. And API apps, not only do we have a whole bunch of built-in ones, but we also have a rich Visual Studio tooling that allows you to build them so that way you can deliver APIs that can be consumed by Logic Apps or by mobile apps or just by anybody on the internet. The built-in API connectors cover a variety of areas. So we have modern consumer SaaS offerings like Twitter or Facebook. We have connectors that can connect to systems that probably existed since before I was born, like IMDb2. In addition, we allow you to connect to protocols other than HTTP. So if you have a system and your orders come in on a FTP server, you can connect to that as well. Finally, and probably most importantly, we also are exposing all of the BizTalk capabilities that existed in BizTalk services as clean API contracts as a part of an API app. And what that means is if you want to be able to debatch an order, if you want to be able to convert from a flat file to XML or back again, if you want to be able to execute business rules on top of something that comes in, you can do that by using API apps. And almost all of the things that existed previously, well, actually, I think all of the green boxes, the first column represents what was possible in BizTalk Services v1, and the second column is what's possible as a part of App Services. And you see we've brought all those capabilities forward. I don't expect you to read this whole slide. I'm sure you can look at the deck afterwards. But really the key point here is everything that was possible before with BizTalk Services is brought forward into App Service as part of either the API apps, which represent kind of those clean contracts, or the Logic apps that are the automation on top of that information. The yellow is somewhat there right now. Our job going forward is to turn all of the yellows green. If everything was already green, I would no longer be employed by Microsoft. So with Logic Apps, there's one key point I want to cover before I jump to the demos. And that is the target for Logic Apps and API apps, App Service all up, is anybody who can use Azure. So that means if you have ever gone to the Azure portal, if you have people in your company who have, they can take advantage of these capabilities. But we don't necessarily expect consumers to come to the Azure portal and build Logic Apps. The Azure portal is full of concepts like VNets and VMs, and it's not really a very consumer-friendly portal, as I'm sure you're all aware of. So we are thinking about how to deliver these same capabilities to consumers, but it will not be inside the Azure portal as you have today. So just something to keep in mind as you're thinking about how we're positioning Logic Apps. So let's switch to the demo. It's all wake up my computer. So what we have here, this is the preview Azure portal, and it has that nice start board, so you can see all of the things that I'm interested in. And I'm just going to create a very simple logic app. So to create a logic app, you go to the plus new button at the bottom left, and all of the components of app service are under the web and mobile category. So here you can see web apps, mobile apps, API apps, and of course logic apps. And for a logic app, it requires you to do a couple things. Well, you have to name it, so let's ignite demo. And then the other thing that you have to do is you have to choose the app service plan. And the app service plan is a very important concept because what the app service plan represents is the thing, it's the thing that you pay for. It's the unit of billing. And it's also the place that all of your code executes. You can think of it as, say, a pool of VMs. So when you create an app service plan, you give a name, and you also choose the pricing tier. This is the set of features as well as the size of those VMs that you're interested in. So you can see here there's a variety of different SKUs that we have, all the way from free, if you just want to get started, up to these big premium boxes that we have as well. And here in the portal, we even show you a little estimated spend, so you can get a sense of how much it would cost to use these various app service plans. When you choose an app service plan, you also choose which resource group it should go into. So the resource group represents that deployment lifecycle. It's that boundary that you put all of the same components into. So if you have API apps and logic apps, you put them together into the same resource group. They'd run on the same plan, and then this plan actually doesn't scale in cost as you add more stuff into it. So if you have 10 logic apps or one logic app, you actually are paying the same amount because you can put them all into the same app service plan. So I'm going to do that. I'm just going to select an existing app service plan because I don't want to pay any more. So I have one that I've set up for the demo purposes. And then click Create. And now what it's doing is it's going to go off and create an empty logic app. Now, what I could have done is I could have actually gone and pre-configured a few different things in it. I could have dropped in my initial capabilities, but just to show you from base 0, we'll just start with an empty one. So this will take a few seconds to get started. And what it's doing right now is it's checking to make sure that the app service plan is set up and running, and then it will create the workflow. So this right here, this is the resource blade for that logic app that I've created. At the top, we have the commands that you can do on top of logic apps. There are things that you would kind of expect. Hopefully, these labels are somewhat intuitive. So you can change the settings. You can cause it to run now. That won't do anything yet because it's completely empty. But hopefully, once you have some stuff in here, you can come here and invoke it. You can, of course, enable or disable them. If you set up a bunch of stuff but you don't want it to run yet, you can click it and leave it in disabled state until you need it. You can, of course, edit or even delete your logic apps. Below the command bar, we have all of the essentials that you need to get started. So, for example, we have here the endpoint of this logic app. And it's a bit of a spoiler for later, but you can actually use this endpoint to invoke your logic app from, say, a website or a mobile application. All of the other details are here. And then below that, we have this big quick start tile, which you can come and check out later. It has links to all of the documentation, the management API, the definition language, everything that you need to get started, and a list of all of the runs. So a run represents a single time that it's executed. So if it's gone off and it's done one thing, that's a run. If it runs again in an hour, that's another run. So you can see that full history, as well as any events that have happened. But let's actually set this up. So whenever you create a logic app, the first thing you have to do is define the trigger that causes it to run. What is causing us to get started? The simplest is to just run it on a schedule. So for the demo purposes, let's just run this logic app once a minute. Now, you can use a variety of different types of triggers. So, for example, you could trigger based on when an API returns some content, or you could trigger based on something external invoking it. Next, let's connect to Twitter. So what we'll do with this particular API app is we are going to go and we're going to search Twitter for interesting tweets about logic apps, and we're going to archive them into my Dropbox. So what I could do with that, for example, is I could then come to my Dropbox later and see what interesting things that people say about logic apps. I can run some business analytics on top of that data because I now have it in my files. And if somebody goes and deletes a tweet, I can always have a copy of it just so I know what good or bad things they said. So when I drop on the Twitter connector here, I get an authorize button, which is asking me to grant logic apps access to my Twitter feed. So this is a standard OAuth dialog here, and I can just click authorize, and that grants this logic app permissions to use the Twitter API on my behalf. Then what it will do is it'll show me a list of actions that are possible to execute against the Twitter API. In this case, there's these 4 simple ones here. You can get the timeline of a user, you can make a tweet, you can retweet something, and we even have little descriptions here so you can see exactly what is going on. And if you aren't satisfied with these actions, we have a menu here where you can see the full set of APIs that are possible as part of Twitter. But we don't need to go in and use any of these today, so I'll close that up. So like I said, what we're going to do is we're going to search Twitter for information about logic apps. So I can come in here and I can specify a query. Now, just like with the list of actions, there are also optional fields here that I can open up. So for example, I can set the maximum page size. I don't need to do that right now. So then I can just click OK. So the next thing I'm going to do is I'm going to add in a Dropbox connector. Now this list over here, it looks like it's just a list of existing SaaS connectors that I've created, but you can actually put your own APIs into this list. So if you deploy your own API app that talks to your own internal business system, that will also show up in this list right here, and you can use that to orchestrate over something that's happening inside of your business. It doesn't just have to be these SaaS connectors. So when I dropped on Dropbox, again, just like with Twitter, it's going to ask me to authorize. And I think I already authorized Dropbox before, so it just kind of accepted it. And then, as with Twitter, it shows me the list of actions. Now, one important point here is all of these capabilities are entirely metadata-driven. So that means nobody had to go and build a bunch of custom UI for these connectors. And it also means you don't have to build any UI for your APIs either. All you do is you expose a metadata format called Swagger. It's an open source format that is used. And that Swagger just defines the set of capabilities, in this case, the set of actions, as well as when I have a particular action, what inputs it takes. As well as with inputs, it can also provide all of these descriptions, so that way people can fill it out more effectively, as well as type information, so that way we can know what a valid input is. So to upload the tweets into my Dropbox, I can just type in my file path. So I'll type, logic app tweets.txt. And then here's where the power of logic apps really comes, in that I can flow data from previous steps into this one. So I can select, for example, the tweet text. And what this means is data will come from Twitter, and then we will automate on top of that and call Dropbox with the content that came from Twitter. So I can just click the check mark. And finally, I can save it. As soon as I save it, this logic is live and executing up in the cloud. So if I come to Dropbox over here and refresh this, if I'm lucky, there will already be a file here that contains a tweet about logic apps. Let's see. So here we go. Logic app tweet from 1 second ago, so down to the wire. And we can open this up, and I can't read that. But hopefully it's something positive about logic apps. So you may notice here, though, there's only exactly one tweet. So this isn't particularly good, because what I've done wrong is the Twitter connector, it outputs an array of tweets. It doesn't just output one tweet, but if you remember, it actually is going to output 20 tweets at a time. So this logic app isn't quite configured properly yet. So I can come back and I can continue to edit this. So I just open the gear menu here and I can edit. And what I actually want to do is take advantage of a capability called repeat, which allows you to iterate over a list of items, and for each item in the list, execute this action. So I can do that by selecting repeat over a list. And when I do this, I can again choose the outputs of a previous step, in this case, the search tweets. And then I can reference the particular tweet that I'm currently iterating over inside here. So for the file path, first, instead of putting it all in the root of my Dropbox, let's create a folder. So I'll just do logic apps. And then I add a slash, so it's just a simple file path, right? And then to reference the tweet, I can do something called repeat item. So you may notice there's these little functions that we have, like body or repeat item. These are expressions that you can use in order to be able to construct content as a part of a logic app. This is all fully documented, and the examples and tutorials online cover this as well. But it works just like JSON, or just like JavaScript. So you can reference into particular properties of these things as well. So I can take the repeat item and type, for example, the tweet ID. So what this does is this creates a file where the name of the file is the identifier of the tweet. The other thing that I want to do is, instead of taking just, say, the tweet text, I want to flow in a couple different pieces of information. And I can drop them in consecutively from this menu here. So in addition to showing the tweet text, I also want to see who tweeted it. So I can add tweeted by in as well. And that just adds these different parameters in. So you don't have to type these functions if you don't want. You can just use this menu and add as much content here. And I can even come back and edit this a little more, so I can say, was tweeted by. And I can click the check mark. And if I click Save, now within a minute, what I should expect to see is in my Dropbox, I'll have, did I close it? Let's see if it signs me back in. In my Dropbox, I should have a folder called Logic Apps that contains multiple tweets. And inside that folder will be not just inside those files will be not just the text of the tweet, but also who tweeted it. So let's come back here and refresh this. This, of course, assumes I didn't make any typos, which happens pretty frequently. Well, it's not there yet. But what we can do is we have full debugging capabilities built into Logic Apps. So if something goes wrong, if I made a mistake or maybe it's just running slow, what I can do is I can close out of this designer here. And I can see, remember this tile used to be empty. This now shows me a list of all of the times that the Logic app has run. And I can even make it run manually, and it'll add another item into this list. So of this list of runs here, you can see that the one that I just did failed. And I can actually click on that, and I can see the full details of this action. So in this case, the Twitter connector, it succeeded. So I can click on that, and I can see what information I passed to it and what information I got back. In this case, I will expect to see a whole bunch of tweets came back in an array. So you can see here somebody is probably tweeting from this very session right now. I hope. Maybe they're in a different session tweeting about how interesting it is. And then I can click on the Dropbox connector and see exactly what happened there. Just as before, I should expect to see an array of things. So I can come here, and I can see, oh, look, it looks like it did succeed. But it took a little while. It took 16 seconds, so maybe I was just, oh, there it is. I didn't give myself enough faith. So you can see here, I can see now the list of all the tweets, as well as inside here. So you can see, looking at Logic App's feedback and who it was tweeted by. So this is that process that I just created. So let's do one more thing before I go back to slides. And inside this definition, right now I'm getting a bunch of tweets into a folder, but I actually don't know how important these tweets are. These could be some random person on the internet that has no followers, or a tweet that nobody really cares about. So what you can also do inside of Logic App is you can add conditions or filters on top of the action. So I can come here and I can edit this action again. And then I can go to add a condition to be met. And inside this condition, what I have to type is an expression that will result in either true or false, right? So I can type greater. So I'm going to do a comparison of the repeat item. Again, this is the tweet, and I'm going to do retweet count. So what I want is I want only tweets that have a retweet count greater than 0. So a tweet that somebody has retweeted probably is a bit more interesting to hear about than a tweet that nobody has ever seen or done anything with. So again, here's that simple function, and retweet count. And you can say here, you can see here's the retweet count property, and it's greater than 0. So this is just a function that takes 2 parameters and compares them and returns back true or false. And actually, what I'm going to do is I'll dump this to a different folder, just so that way you can see the difference. So I'll do important logic apps. And let's change this to true as well. And when I click Save, now what I would expect is, again, within a minute, and I can manually run this as well, I can see a folder not only called Logic Apps, but there'll be probably another one called Important Logic Apps. And I would expect to see fewer tweets inside this one. And in fact, I do. So these are just the tweets that people have retweeted. So these potentially have something interesting going on with them. And I can then take these, and I can do my own interesting business analytics on top of this data. So that is the first introduction to Logic Apps. So I'm going to switch back to the PowerPoint here. See some more tweets coming in. What I showed is basic automation in the cloud using Logic Apps. So I took data from one API and passed it to another API. And I did some additional logic on top of it. So instead of just flowing it blindly, I did a little filtering, I did a little repeating, and got what I wanted inside of my Dropbox. So what we did here is we implicitly orchestrated on top of these APIs. We executed Dropbox after Twitter. But you can also do some other more advanced capabilities. For example, you can make any number of actions appear in that workflow, and you can execute them in any order that you define. And you can do that by building dependencies between each of these actions. So you could add another action and say, I only want it to run after the Dropbox has successfully uploaded my files. Another capability I showed was repeating, which allows me to take a list of items and execute the action for every item in that list. You can also, of course, just pass in an array of numbers, 0, 1, 2, 3, 4, 5, if you want to repeat over multiple lists, because you can dereference the index of that item in the array. You can also do conditions, which is what I showed here. And you can do conditions not only for actions, but also for triggers. If you want to say, only execute on Mondays that start with the number 1, you could also do conditions like that as well. So now that I've given a brief demo, let's talk about the architecture of Logic Apps. Where did Logic Apps actually come from? So if you saw a couple of the Mark Russ demos earlier in the week, you actually saw him deploy hundreds of nodes in a cluster into Azure in under 5 minutes. And the way that happened is by using the Azure Resource Manager. So Azure Resource Manager is what allows you to deploy complex deployments into the cloud. And Azure Resource Manager actually does automation and orchestration on top of that. So for example, you need to create a VNet first. And then you need to add the network interface from that VM into that VNet. And then you create the VM and point it at that network interface. It's pretty complicated, although Mark makes it look very simple. This architecture, we realized, could be used for any type of orchestration in the cloud, not just for deploying resources into Azure. And what was great is it was cloud ready from the beginning. This architecture can handle thousands of parallel deployments per stamp. It's resilient against failures, which means if something goes wrong, we have retry built in, and you can also define your own custom steps for when something goes wrong. There's a simple declarative JSON language, which I'll talk about, that allows you to define exactly what you want to happen up front. And we automatically infer dependencies between actions. So all these capabilities already existed in Resource Manager. But we didn't stop there. We have also added a large number of functions on top of what Resource Manager has built in. So with Resource Manager, you can just deploy resources to Azure. But with Logic Apps, there's over 50 functions that we've released, such as things like math operations, set operations, logical operators. I showed you the greater than, for example. So you can do all types of basic processing just right inside of the Logic Apps engine. Additionally, we support calling any arbitrary HTTP endpoint. And with connectors, we can even call protocols that aren't HTTP, like FTP, as I mentioned. We support a variety of different types of authentication as well. So if you authenticate your API using basic auth or AD or a certificate, Logic Apps can call into that. And finally, we have a variety of different ways to be triggered. So real quick, I'm going to switch back to the screen and show you one thing. So this was the designer, right, which shows you the steps as they laid out. But in addition, we also have the ability for you to click on Code View, and you can see that JSON template that I just mentioned. So once this all loads, the network here isn't the best. So you can see here, this is a simple JSON template that describes that same Logic app that I created using entirely the UI. And it looks a little complicated there, but in reality, there are only 4 sections that you need to worry about. Or not really worry, but care, I guess. So there's parameters. So these are the things that you want to reuse across the workflow. Triggers, those are the things that start it. Actions, those are the things that happen. And then outputs, that's when, if you call into the workflow using an API, it can return back those outputs. So let's talk a little bit more about parameters. Parameters are great for reusing values. And this could even be complex objects. You could reuse arrays or objects, dictionaries, really anything you want throughout that Logic app. So if you don't want to type the same string 20 times, you can use a parameter for that. More importantly, what parameters allow you to do is they allow you to separate out config that may be deployment specific from the actual business process that's executing. So for example, if you have a process that you want to execute in a test environment and then move that into production later, you will take the config that's unique to, say, the test environment or the production environment. You will factor that out into a parameter, but you'll leave that definition the same. That UI that I constructed will look exactly the same in both my dev and test environments. But instead of having a hard-coded endpoint, for example, I would reference a parameter. I'll show an example of that later. Triggers allow you to execute content on a recurring interval. And we support a variety of different types of triggers. For example, I showed recurrence earlier. We also support calling into any arbitrary HTTP endpoint and triggering based on the content of that response. So for example, instead of constructing the workflow the way I did here, I could have actually used a Twitter trigger and had Twitter fire only when there was a new tweet available. In this case, this workflow will execute every minute no matter what, even if there are no tweets. But you can use triggers to execute only on demand when you need it. And the API can define that data. Additionally, state can be maintained across executions. So if you don't want to maintain state in your own backend, you can use triggers to maintain it on your behalf. For example, if I'm polling Dropbox and asking if it has any new files, each time I poll it, I can tell it the list of files that I already have. Actions allow you to perform a call out into any endpoint. It can be HTTP or an API app. Actions can even be other Logic apps. So I can use one Logic app to call another process. And that's particularly useful for looping scenarios where if I want to have kind of one giant for loop and then another for loop inside it that iterates on top of that, you can do that by having logic apps that call other logic apps, workflows that call other workflows. Another important note about actions is they can be either synchronous or asynchronous. So when I call the action, it doesn't have to finish immediately. It can actually wait for some state to be updated, for somebody to approve something until that action can return. So you can use it for example, human approval workflows if you want, where until your manager approves something, the workflow will not continue. Finally, template language expressions are those little @ symbols that I included inside of the workflow. That's what allows you to do all of the advanced capabilities. So you can do static things like summing two numbers together, or you can do something that varies at runtime, like take the outputs of the previous action. There are also two different ways to do this. You can just reference it directly. You can also include it in a part of a larger string. So if you want, for example, to do that where I did with Dropbox, I put in multiple fields into the same item. So you can kind of use as many different tokens or as many different expressions as you want. So let's move on to the next demo. Great. So in addition to being able to create the logic apps inside of the Azure portal, you can also create them from Visual Studio. So I can go to File, New, Project. I choose Azure Resource Group. And then, just as before, you're going to see, again, these capabilities that we have in Azure App Service. So you have your web apps, API apps, and logic apps. And you can even create a template, for example, that deploys logic app and web app at the same time. Grab some water. So logic app, let's just create an empty one. So this creates this Visual Studio project for me, and it's pretty simple. It just has a script to deploy, and I open this file up, and you're going to see here's the template for the logic app. And inside here's that same definition that you saw from the portal, as well as I showed on those slides. So what this logic app does is this just pings a site every hour. What's great about using Visual Studio is there's built-in IntelliSense. So when I come in here, it's using this schema, so it knows, for example, what the different frequencies we support are. So I can click on seconds if I want this to run maybe more quickly. So I can run it every 15 seconds rather than once an hour. Now, in this case, it's going to ping a website. But I should do something interesting if this website fails, right? So what I want is I actually am going to send myself a text message every time that this website goes down. So I can add another action in this list of actions. And again, with IntelliSense, it shows me what parameters can I fill out. So I can give it a type, for example. And when I give it a type, again, IntelliSense is showing me, hey, I have a type called API app. Next, I can give it some inputs. And I've already constructed my inputs here, so I'll just copy this in. And what these inputs are is they tell me which API to call. So this is the URL of that API app. You can actually go get this from the portal if you wanted, but I already did, so that way you don't have to wait for me to do that. The operation that I'm calling, in this case, send message, just like there was upload file, here I'm going to send a text message. And then the parameters that the request takes, in this case, the phone number that we're going to send a text message to, and the content to send to the text message. Again, you can see I'm flowing data between steps. In this case, I'm flowing the code of that Dropbox step here. As well, I've set up authentication so that way not just anybody can call into that logic app. So the other thing I need to do is I need to add a condition to this action. I don't want this to fire every time that it pings my website. That'd be terrible. I get a text message every 15 seconds, right? Instead, what I'm going to do is I'm going to add a condition that says execute this only if the ping to the website fails. So this is how you can do failure handling as a part of logic apps. So I can come here. Again, here's all this IntelliSense showing me. I can type an expression here. So what I'm going to do is this will be a bit more complicated expression. So I'm going to do a not, and then an equals. And I'm going to take the action dot status. So this returns back, success or failure, running, basically whatever the status of that ping is. So I can take that and I can compare it to the string succeeded. So now what will happen is every time, that text is really small actually. Let's see if I can make that a bit bigger. Does anybody know the keyboard shortcut? That's weird. This way. There we go. There we go. Hopefully that's a bit more legible. So you can see here, not equals, and then the status succeeded. So it's a little, you kind of have to think about it a little differently. It's just a series of functions that we're calling, right? So these functions are not case sensitive, generally, no. The only time that things would be case sensitive would be if you're doing like a string compare. So if you have two strings, you can do a case sensitive compare if you'd like. Great. So now let's save this. And now I want to deploy this into Azure. And it's actually very simple to do that. I can right-click on this project that I created and go to New Deployment. And you see I've already signed into Visual Studio, so it's going to show me my list of subscriptions. If you weren't already signed in, it just takes a few seconds. Then I can choose which resource group to deploy this logic app into. And I'll choose that same resource group that I've been using before. I choose which deployment template to use, and the set of parameters to pass into that logic app. So I can click Edit Parameters here, and I can choose exactly what to say. So in this case, let's call this logic app ping test. And we'll use that same plan that I've been using, the AV demo plan. And instead of pinging the Azure status page, which should always be up, I'll just ping, I'll just ping a website that I have running inside this resource group. So that way I can turn it off when I want to. Then I click Deploy. And this will go, and this will run the scripts to deploy this right into the cloud. And if I go back to the portal here, and let's see, is this done yet? Template is valid, create deployment. I created the resource group. Succeeded. Succeeded. Great. So if I come here now, I'm going to see, hopefully, that new logic app that I just deployed from Visual Studio. There's Ignite demo. Did I choose the right resource group? Let's find out. So I'm going to click on this website, and I'm going to stop this website. So when I stop this website, what should happen, hopefully, is within 15 seconds or so, I should actually get a text message to my phone. Now, of course, this website has to load before I can do that. So here I'm just using the Azure portal. Here's just with web apps, you have the same type of experience that you'd have with logic apps. Commands at the top, the most essential capabilities. You can do monitoring, for example, see the requests that this site has had. Very consistent experience across all of the different components inside of Azure. So here I'll stop this. I'll hit yes. So now the website is stopping. And once this stops, then that logic app should be pinging this website regularly and return back. I don't know if you heard that, but I got a text message. It says the system is down. So I have now just constructed a simple logic app that based on a condition. And actually, I should restart my website because this is going to ping me every 15 seconds. So before I use up all of my text message quota for the month, I'll do that. I'll just put this on vibrate. So with logic apps, you can create your own remediation steps, your own failure handling as much as you need in order to handle whatever may happen inside of your business. And I'm hoping this spins up. So the other demo that I have is the ability to use some other application out there to kick off a logic app. So both the examples I've shown right now are just based on a schedule, right? You can also invoke something based on an API call from if you have a mobile app or a website to kick something off. So what I've done right here is I've created a simple web page. It's very ugly, but it uses Bootstrap, which you may be familiar with. It's nice and responsive. And what this does is this allows me to add an invoice. And when it adds the invoice, it's going to ask my manager for approval. My manager in this case is my phone. And if I approve it, it is going to update and say that it's approved. So again, what I should be able to do is, and let's actually look at what this logic app looks like. It's a simple, it's 2 steps right now, and it will have that HTTP call, which will be used to invoke it, as well as the call to Twilio to send the text message. And what you'll see here in a moment is also the card that represents that Twilio action. So just like I constructed it entirely inside Visual Studio here, you can see that it's actually identical in appearance, well, not appearance, but in terms of data content here in the portal. So you have send message, the from number, the to number, etc. So I can come here and say what item I would like to invoice. I really need a new laptop. And click Approve My Order. And when that happens, so I just got a text message. My phone vibrated. And it fired off that app in Logic App running in the cloud. Now, to do this was very simple. So I can show you the code that backed this web page. So let's just go to my desktop. It was a single AJAX call. So this is just using AJAX right here. In this case, here's that endpoint that I alluded to earlier. And you can get the endpoint for your Logic app by just going to the essentials here and copying this. For Logic apps, you can use either basic auth or AD auth. In this case, basic is easier because this token doesn't expire until I roll the keys. And you can get this key right here by going to Settings and then clicking on Properties, and you'll see the key floating at the bottom. So here's the primary access key. And then it's a post, so it's just a post call, HTTP post, with the data that I want to actually send. So in this case, from that, I am taking the value of the item. This is from the text box that I typed in, as well as the phone number, the phone number to approve. There we go. Now, what's great about Logic apps, though, is they allow you to factor your application such that you can change your backend logic without changing your applications. So let's say, for example, that in this scenario, I wanted to, in addition to sending a text message for approval, I also wanted to create a list online that lists all of the things that have been approved. So that way I can come back, I can audit that. Now, if you had built all that logic into your application, I'd have to come in here, I'd have to add another call, and I have to do error handling to figure out, when the first call fails and the second one succeeds, does it actually go? I have to build all of that into my application here. But instead, what I can do is I can actually come to this logic app, and I can just add another step. So for the purposes of the demo, let's just add a Yammer group that tracks all of the invoices that get approved. So I'll click on the Yammer connector, and just like you saw earlier, this will add on a Yammer card. It'll show me the list of actions that Yammer supports, and then for Yammer, it'll show me the inputs that it takes. In this case, post a message, and I have my Yammer invoice tracking up here. So the group ID, it's an opaque string, it's 506, and as before, I can flow in that message text from, in this case, the body of that text. And the body, again, I just defined it right here in the call that I made to the Logic App API. And I'm now lost. Oh, there we go. So I'll click this. And as soon as I click Save, this Logic app has now been updated and running in the cloud. So I haven't made any modifications to my web application here, or if this had been a mobile app, basically anything that can do an HTTP call could do this simple call. So I've made no modifications, and I also need new monitors to go with my fancy new laptop. And when I click Approve My Order, now, in addition to getting this text message, which I just got, I should be able to go to the Yammer group, and if I refresh this, if everything worked, I should see more monitors show up at the top of this post. Yes, so you may have noticed that I would not recommend doing that. Well, the endpoint isn't quite so bad, but the fact that my key is in the JavaScript page, which I downloaded, it would not be the right security pattern. You'd run that in your web backend, would be the normal way to do it. I just want to show how easy it could be. But you can see here, 40 seconds ago, new monitors. So without modifying my application that's running, in this case in JavaScript or in whatever, I was able to update my business process, do additional automation on top of that in the cloud. So let's switch back to the slides. So just to do a recap, with App Service, it brings together the capabilities of web applications, mobile applications, logic apps, and API apps. And there's one other great thing that was announced actually last week, but it's App Service environments. And App Service environments are great because that allows you to take all of these things, that App Service plan that's running, and run it on compute that's dedicated just to you. So you can choose, for example, to connect it to your virtual network for your on-premise capabilities. So if you want to be able to have internal APIs that are not publicly exposed to the internet, but call them from Logic Apps, you can do that as well. You don't need to wait for Azure Stack to be available. You can actually do that today by taking advantage of App Service environments. And the other cool thing about App Service environments is it gives you more control over the hardware that you deploy. So if you want to use, for example, VMs that have SSDs or faster processors, you can do that using App Service environments. So Logic Apps and API apps are in public preview, so you can try them out today. And imminently, you will be able to submit API apps into that gallery, that right-hand pane that I showed you. One final point that I want to mention is we are very focused on getting feedback from you guys to understand what your pain points are, what you would like to see fixed, and what new features you'd like to see added. So we are going to be very heavily feedback-driven in our development. We're not going to necessarily publish a 5-year roadmap of what we're going to do because we need to hear from you as to what your important features are. So that's kind of the key point that I want to take away here is, come tell me afterwards what you'd like to see. Send me an email. We also have user voice, so you can vote on which ideas you think would be great to see as a part of app service or API apps or logic apps. Also, there's a great community here. You can reach out to me on Twitter. And for the remaining 15 minutes, hopefully we can do some Q&A. There are mics here, so I think you should probably come to the mic so everybody can hear what you want to know. Sure. And I'm assuming the decks will all be posted as well. This one? Okay, cool. Yeah, go ahead.
Yeah, can a new message hitting the queue be a trigger for a logic app?
Yes. Yeah, you can absolutely do that today. In addition to the triggers that I showed, we have an API connector, for example, that uses Azure storage. And that API connector exposes a trigger for queues, or if you want to trigger when a new blob is available. Basically, you can trigger on a wide variety of events inside of Azure.
The conditionals that you showed, if you wanted to build a logic to say, fire this step or this step, depending on the output of the previous, you would just create two steps that both depend on the previous step, and then just modify the conditionals in each step.
That's exactly right. Okay. You could do, if you wanted to do two mutually exclusive steps, you can do that. You could do a switch statement. You could have effectively n steps that all depend on different conditions. They don't necessarily have to be mutually exclusive either. You could do this or both, depending on what conditions you define.
When you had timer-scheduled logic apps, was there a way to control the concurrency of the logic app so that if logic app takes a minute and 10 seconds to process, but you got a timer of 1 minute, that only one copy is running at once?
Not easily today. So the way the timers work is they will fire every 15 seconds, irrespective of how long the execution took. Now, if that was really important to you, what you could do is you could take a lock on some external state and wait on that lock to come available until your logic app starts executing. But it's not built in.
Effective dates and versioning?
What was that?
Effective dates. So can I specify a date when a app becomes effective?
Yes.
And or can I version workflows?
Sure. So you can use, there's some date functions built in. So you can do if the date is greater than whatever the date you define is. There isn't a first class feature for it, but you can just use a condition for it. For versioning, one note about versioning, each time that a run starts, it's pinned to that particular version of the workflow. So if you go back and if I delete a step, but some thing is currently executing, that thing won't be modified. That will continue to execute just like it did before. There isn't a way today to have kind of two parallel versions executing at the same time. To do that, you just have two separate definitions. And then you could even, because you can do definitions inside definitions, you could even have a master one that, depending on which version you want to call, you can call either one.
So with regards to the versioning, I make a modification. Anything that's executing will execute completely. Then the next new thing that comes in would execute on my new flow.
Yes.
Okay,
that's
great.
Exactly right.
I had a related question, but I just lost it. Well.
All right.
So do you have the states in those connections? Like you can keep them the states active? Like for each execution, I want to keep the state active of the previous execution. Can you do something like that?
You mean like keep the connection alive?
Yeah.
So we don't have that capability today. Each execution that we call is kind of independent. And the reason that we do that is we don't want to burn a lot of resources on the connector, so we don't want to keep a bunch of connections alive. So basically, you can think of it, the whole thing hydrates, it runs, and then it dehydrates. So it's not using a bunch of resources.
Okay. In your example, you were showing some out-of-box connectors. Mm-hmm. Can we build those our custom connectors there and pull in?
Yeah, so you can build, so if I had done the Visual Studio template that was the Logic App plus API app, what that actually does is that gives you a scaffold for creating your own custom connector and referencing it from inside of the Logic app. So your own custom connectors, if you just code them up, there's a whole bunch of docs online, and I think there is a session on API apps here. If not, there was one at Build you could look at. That they will show up in that right-hand pane that you can click on and you can use just like any other of the built-in connectors.
Thank you.
Hi. How does an end user approve one of the connectors to act on their behalf? For example, posting to Yammer.
Yeah, so that uses the OAuth flow that I showed. The Yammer one didn't ask for my approval because I had already approved Yammer. But like the Twitter one, for example, that threw up that OAuth dialog, right?
Right, I must have missed that.
Yeah, no, that's fine. So that is kind of interesting, though. There are two types of authentication that we talk about. One is when kind of the workflow has the identity. So that's when I go and I build that Logic app, I approved Twitter to use my personal Twitter account, right? So every time that Logic app runs, it'll use my Twitter account. And the other type of identity we talk about is useful in the context of mobile application, where let's say you build a mobile application and you have 1,000 users that want to use it. And inside that mobile application, you have a button that says, retweet and do something else, or whatever it is. At that point, you actually don't want to use your Twitter account. You want to use the end user's Twitter account. And the way you can do that is if you have built an OAuth flow into your mobile app, you can actually flow that Twitter token as a parameter to the execution of the Logic app. So that way, when the Logic app runs, it can take the Twitter token and do on behalf of that particular user.
Right, thank you. That's great.
So if you wanted to do change control, would you recommend just, for example, if you did all your changes in the UI, then you would take the export of the template, put that in TFS or Git or whatever.
Yep.
And then anytime you wanted to change it, you'd always make sure to keep that as your change record.
Yeah. If you're interested in source control, I definitely probably start from VS, create a new project, check that into Git, and then you can open that up in the UI, make changes, and then once you're ready, commit it back into Visual Studio or Git, or if you want to use a Mac.
Right. Thank you.
But there's no direct connection at this point?
No. So that's kind of an interesting point because generally we think of the stuff that's checked into source control as being the source of truth.
Yeah.
And what you edit in the portal is the thing that is currently running. So it's not a direct connect. It's not like the portal connects to your Git repository, if that makes sense.
It does, but the point is I could make some changes up there, and now I got a couple extra steps to get it back. I mean, this isn't the only scenario where that happens, but you try to
that's
avoid
absolutely
them.
right. And it's interesting. That is actually something we're thinking about, and Visual Studio Online, I don't know if you've heard of that, that actually does have the ability to edit your files in a Git repository inside the Azure portal, but we haven't really done any integration there quite yet.
And I remember my other question. So if I have many, many instances of a workflow running and I find out that it's wrong and I want to cancel them, can I cancel or kill?
Yes. Yeah, so there's a cancel. When I showed that table with each of those runs, at the top of that page was a cancel button. I could just click cancel on it.
And is that PowerShelled available? So if I have, I happen to have 100 or 1,000 or something crazy?
Yep. Yeah. Okay. So we have full REST API, PowerShell, flat CLI support. So you can use that to get your definitions. You can use that to update your definitions. All that stuff.
Cool.
Great. Any other questions? Feel free to come up afterwards. I'll be around. I have cards. You can reach out to me. And just let us know what your feedback is. Love to hear one-on-one what all you're interested in. Thanks a lot.